Okay, all right. So logarithmic differentiation. Yeah, a lot of students haven't been shown this in the past. So here's the big idea of logarithmic differentiation. If you have y equals some function of x, and if this function is nasty in certain ways, that I'll elaborate on in a second, then what you could do is just take a natural log of both sides of the equation. And this will allow for certain really nice things to happen under certain circumstances to what this expression looks like, and you'll see why in just a moment. But in the process of taking a derivative, if you take a derivative, then on the left you get 1 over y times y prime. That's no big deal, right? And there's the y prime you're looking for. Right, that's what we wanted to find in the first place, and there it is. And then on the right you have a certain amount of algebra to do. And all you have to do is just remember, don't forget that when you're done, this is not your answer here. Right? Your answer is what you get when you don't forget to multiply that back over. Because what you're really looking for is this thing. Yeah. So let's apply that idea, and let's see, our function here is s squared t squared to the power of st squared. Yikes. Okay, what a weirdo. S squared t squared. Okay, all right. Okay. So y equals s squared t squared to the power of st squared. All right. So now, first of all, let's comment on why we feel like we need to do this at all. You look at this, and I claim that this function is kind of nasty in a certain way. There's a temptation to use the power rule. The problem is, the power rule requires that this be a constant, which it's not. Right? Then there's a temptation to say we can use like a rule of exponentials, but exponentials require that be a constant, and it's not. Right? So this simply doesn't fit in any of our previous forms, and without logarithmic differentiation, we don't have any way to get our foot in the door here. So, but we take a log of both sides, and we get st squared natural log of s squared t squared. In fact, I'll tell you what, I'm going to be clever about this and take this squared out and make that a 2 out there. All right, so that's just using properties of logarithms. Is everybody okay with that? Mm-hmm. Now let's take a log of both sides. Take a derivative of both sides. And now here's where it does get a little bit annoying. By the way, we're taking a derivative. Oh, we're doing both of the partial derivatives. Okay. So let's. So I can't say prime. That was silly. In retrospect, what was I thinking? Partial of y with respect to s. So I'm going to do the s partial here. Yeah. Okay. So now we're taking the partial with respect to s of this thing, and oh my gosh, now there's a product rule. It's going to be kind of a pain. Okay. So let's view that as a product like that. All right. So I get 2t squared times log of st, and then plus 2st squared. And now I got to take the partial of log st with respect to s, and that's 1 over st times the partial of the inside with respect to s, which is t. Lucky cancellation there. And so it wasn't that bad, really. And so what I have then is 2t squared log st plus 2t squared. Now again, the most common mistake that students make on these kinds of questions is to declare this to be their answer, which of course is wrong, right? Our answer is what you get when you multiply y times that. And so specifically then, partial of y with respect to s is y correctly, yep. Times all this business. Yeah. Everybody good? Okay. All right. And by the way, I kind of regret a notational choice that I made here. Let me just point this out because, a lot of students don't see this kind of thing coming. But is that log of st, pause, plus 1, or is it log of st plus 1? And I put a great big blank in there to make it clear in this case, right? But just to really avoid the confusion, why don't I rewrite this as 1 plus log st. And there's no confusion. Okay, no questions? Everybody's good? Okay. Let me stop the recording.
And then we just have to do it for the t partial as well. And then
I'm sorry?
And then we just have to do it for the t partial. And yeah.
Yeah, that's right. Yep. I don't know what's going on there. I hope this recorded